Look at this. This real asteroid is the size of a building, and it's on a collision course for Earth. But can you find it? No one else did either. At 9 a.m. on February 15th, 2013, it's a normal morning in Chelyabinsk, Russia, when suddenly people see something bright in the sky. Some even feel the air get hotter. Above them, that building-sized rock hits our atmosphere going 67,000 kilometers per hour, and 23 kilometers up, it explodes. People come to their windows to see what happened, but 90 seconds later, the shockwave hits. Within 4 days, debris from that blast circles our entire planet. And the scariest part is no one saw it coming.
Scientists had no idea this was coming.
And it could have been disastrous.
What if that rock had been bigger? Imagine, it's 2034, and a rock the size of a mountain, somewhere far off in our solar system, is on a direct impact course for us. How would we know? And what could we actually do about it? In this video, we'll play out a fictional asteroid headed for Earth, with some help from my friend and former NASA engineer, Mark Rober, and rare access into a remote facility where they discover new asteroids.
Oh, look at that. What do you got?
Is that real? To show you all of the amazing, real science and tech that we would use to defend our planet if an asteroid is about to hit Earth. So in order to make sure that you know what's real versus what's our fictional asteroid crisis, I asked Mark Rober to voice the fiction sections, and it turned out so fun.
Let's go. It's 3 a.m. on June 1st, 2034. Scientists inside Catalina Sky Survey in Arizona have been awake all night, hunting for asteroids. Their telescope is taking time-lapse pictures of the night sky in a grid like this. Each spot of the sky is photographed 4 times moments apart, and that lets them find moving asteroids against the stable stars in the background. Oh boy, I'm already nervous, Cleo.
You got this.
It's slow work, and they're tired. But new photos just came in. Wait, that can't be right. That looks like a new fast-moving point of light against the sky. Is that what I think it is? Is that what I think it is?
Yes. Right now, we're at the real Catalina Sky Survey because they've invited us to spend the night with them while they hunt for real asteroids. Since the 1990s, this place and places like it around the world have scanned the sky while we're all asleep, hunting for dangerous objects that might hit us. Together, these ground-based observatories have detected the majority of the near-Earth asteroids that we know about, over 39,000 so far. We don't think about it very often, but our planet is in a constant, high-stakes dodgeball game, and we can't dodge. So our only hope is to identify asteroids long enough in advance to do something about it. We're the only species to ever have a hope of doing that. For anyone else, when an asteroid comes. The asteroid that killed the dinosaurs was wider than Mount Everest is tall. But what I didn't realize is that asteroid, it wasn't that big. At least not compared to other asteroids that have actually hit Earth before. Imagine hunks of rock or metal, all different shapes, up to about the size of a 10-story building. There are likely millions of these flying around closer to us than Mars, and they hit us all the time. But our atmosphere protects us. These small asteroids almost always burn up long before they reach us on the ground. But asteroids get bigger. From the size of a building to about 2 city blocks, there are likely hundreds of thousands of asteroids this size near us. On June 30th, 1908, a rock 50 meters across grazed our atmosphere over Siberia. It never even hit the ground, but just the shockwave flattened 80 million trees. And if it had hit, well, an asteroid impact is worse than you might think. Most people imagine an asteroid hitting Earth like a bullet hitting a wall. But an asteroid is not like that. An asteroid is almost always going so fast that when it hits, much of it immediately turns from a solid into a superheated gas that explodes outward. And the energy of that explosion is insane. A 50-meter asteroid would release the energy equivalent of around 500 nuclear bombs. That's why this size is called a city killer. But they get bigger. Anything this size would wipe out a whole country. And anything bigger than that, all life on Earth would change forever. That rock that hit the dinosaurs caused mega tsunamis, a thermal pulse of heat and fire, dust and ash that blocked out the sun for a decade or more. But that's nowhere close to the largest rock that has ever hit Earth. 1.8 billion years ago, a rock nearly 15 kilometers wide slammed into what's now Canada. And 170 million years before that, the largest asteroid that we have evidence of ever hitting Earth, 20 kilometers wide, struck what is now South Africa. If you'd been on the ground and looked up, an asteroid that size would look something like this. And even bigger than that, it's theorized that an object the size of Mars hit Earth about 4.5 billion years ago, and that's how our moon was formed. But something I found interesting when talking to experts about this is that not all asteroids hit our planet the same. An asteroid made of ice and rocky debris might hit our atmosphere and break apart, burning up on entry, while a dense metal asteroid of the same size could pierce straight through and maybe do more serious damage. But the good news is that based on our rate of discovery and computer models of our early solar system, astronomers say that we've already found about 95 to 98% of the really big asteroids, the ones about a kilometer wide or more. As of today, there are exactly 877 of them, and scientists track them very closely. And luckily, none of them are on track to hit us. But those city and country killers, for the country killers, they think we've only found 42 to 47% of them. And for the city killers, the number is much, much less. And we're much less certain about that percentage. That is the biggest hole in Earth's defenses right now. And that is what people all around the world are staying up all night trying to fix. And I'm about to become one of them.
So we just opened the doors to the telescope. We're now all set to start the observation run. We just have to wait until it gets darker and then we can start hunting asteroids. They told us that based on the weather, we might find a brand new asteroid tonight. So I have my fingers crossed.
As we waited for the sun to go down, I found out something that made me very excited.
If you find a new asteroid, you get to put your name on it. And I really want to do that.
But it turns out finding a new asteroid is way harder than I thought.
So this is a map of the night sky that shows the coverage from this telescope over about the last 2 weeks. We'll cover the entire night sky about twice a month.
The telescope takes pictures of 12 spots of sky at a time, each 4 times in a cycle. So the 4 images of each spot are brief moments apart. And then an automated system analyzes each set and shows the observer just the maybe options. The vast majority of those are still no's.
So you see the N key is a little worn down on the keyboard. That's the key we hit the most.
Okay, here I go.
Not real.
Okay.
Not real. Nope. 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 Definitely nope.
This went on for hours. David and I took turns, and I really wanted to stay awake. So I did a ton of push-ups, and I drank a ton of coffee. And when I was at the observatory, I drank whatever coffee they had. But when I'm at home and I can choose, this is the really good stuff. It's from Cometeer, and the reason why I love it so much is because it's delicious. I genuinely drink their coffee all the time, and because it's genuinely cool technology. Even if you buy great coffee beans, it's hard to make a great coffee at home, and that's why I've been using Cometeer. This is the first coffee that's brewed to perfection and then flash frozen at peak freshness, which makes a big difference when it comes to taste. So Cometeer goes out and they find the best beans from roasters around the world, like Intelligentsia and Onyx, and then they brew the coffee at 10 times the strength of a normal cup, and they flash freeze it into a capsule like this. Then I can just take that capsule, and without a machine, you can just pop it out like this using the eject button. And then you can make it hot or iced or an iced latte. Boom! The perfect cup every single time, and it took less than a minute. Plus, it's got twice the flavor and caffeine of a regular cup. Perfection. Right now, this one is my favorite flavor, but you should try it out and comment yours. So if you're sitting here and you're thinking, man, I would love a good cup of coffee, try Cometeer. I think you'll like it. And if you haven't tried Cometeer, you can get $20 off your Discovery box, featuring 8 unique coffees curated by World Barista champ James Hoffman by visiting cometeer.com/Cleo or visiting the link in my description. But back at the observatory, it was hard to stay awake. And at a certain point, I found myself wondering,
why is it that you need to be physically here as opposed to you have this amazing software, it detects these images, you come in tomorrow morning and you say, that's real, that's not real, that's real, that's not real.
The turnaround time on the data is critical.
Because those 4 images, they only show a tiny little piece of an asteroid's path. So if you waited until the morning, you'd probably lose it.
If you don't continue to track that object and publish it immediately, it literally can get lost.
So when you find something, you immediately send it to what's called the Minor Planet Center to check if someone else has already found it. And if it's a new object, other telescopes around the world lock onto its position to help build out its orbital path for the foreseeable future. This is all public. Anybody with a telescope can help. And we'd all need to help if anyone found anything big enough.
The observers are still staring at that moving speck of light. Something that bright is likely an object we know about already. So they report it to the Minor Planet Center. And normally, they'd be hoping to make a new discovery. But today, they're just hoping their suspicion is wrong. And as soon as the report comes back, the whole team goes silent. No one's ever seen this thing before. It's a new asteroid, and it's big. Cleo, you're making me narrate the end of our species. Astronomers around the world spring into action. They need to know how big and what it's made of. And, most importantly, will it hit us? How will they know what it's made of from their telescopes?
You're about to find out.
Cleo, you've thought of everything.
Breaking news.
Reports of a new asteroid.
Concerning news emerging,
New report just in.
Scientists are warning.
there are rumors of an
Concerning
asteroid.
reports of
Scientists
circulating
still
here.
verifying
Or what
the
level
signs.
the public is beginning to wonder. Are we in danger?
The new asteroid gets its official name, 2034 LV1. But as news spread, astronomers nickname it Soteria, after the Greek goddess of safety. It's a bad joke. Data is now beginning to stream in from around the world, and it's not good. Soteria isn't just big, it's really big. Observatories shoot radio waves at it and time how long it takes the echoes to return, measuring its size and shape with high precision. It's 400 meters across, a country killer. And what's worse, it's dense. Every mineral and metal reflects light in its own pattern, so scientists analyze the light bouncing off Soteria like a fingerprint, and it turns out it's made of nickel and iron, and it's fast. By carefully mapping its position in the sky, they see it's racing through space at roughly 75,000 kilometers per hour relative to Earth. Why didn't we see it before? Scientists checked back in all Earth records. Turns out, it was too close to the sun. Whenever it was observable, it was in the daytime sky. The only question that really matters now is, will it hit us? Analysts put all the tracking data into the world's most powerful computers and solved for Soteria's trajectory around the sun compared to ours. And at first, the odds of impact are 2%. That's already huge by astronomical standards. But as more and more data comes in, that impact probability climbs higher and higher, until we know there's nearly 90% chance Soteria will hit us when it comes back around in October 2041. But all this learning takes time. Months have gone by. Now it's already 2035. And now we know the question isn't if Soteria will hit us, it's what can we do about it? With an impact date of 2041, we have 6 years warning. 6 years to do something.
So let's pretend this is your 400 meter wide object.
There it is, that's my object.
That's your object. So it's coming in, and what you'll notice is that it has an orbit that intersects the Earth's orbit very closely. You might think you have to do this dramatic thing to move this asteroid out of the way, but you don't.
So what's the real plan? If an asteroid that big actually were coming for Earth, what do we do? Well, in 2013, the United Nations created 2 groups for exactly this situation. One, to gather information from astronomers around the world and share it with governments, and the other to bring the space agencies together to make a plan. Imagine being in that meeting. Here are your real options. Option 1, you do nothing. That doesn't seem like a great plan, but there is still a chance that it misses us. Option 2, you smash a spacecraft into the asteroid to change its path just enough so that it misses Earth. That might sound like science fiction, but we've actually done this in real life. In 2022, NASA deliberately slammed a spacecraft the size of a vending machine into an asteroid the size of a few city blocks. It was called the DART mission. The asteroid wasn't headed for Earth, it was just a test. DART hit the asteroid at 22,000 kilometers per hour, and it worked. In fact, it was way more successful than they expected. NASA's goal was to change the asteroid's path by 73 seconds, and instead they ended up changing it by 32 minutes. 25 times more effective. And DART was small, but there are already blueprints for a bigger mission, like HAMMER. HAMMER would be modular, multiple parts stacked together like Legos, and altogether it would be much, much more massive than DART. Basically a big space battering ram for defending Earth. But the downside of this option is it only works if you have enough warning. You need years to build and launch the spacecraft and hit the asteroid and let that tiny little nudge add up into a miss. So you might want to also consider option 3. You nuke the asteroid. But not to explode it, like in a movie, because that might actually create a bunch of dangerous fragments that would get pulled back together by gravity and hit us anyway. Instead, the idea is that you nuke an asteroid just on one side to vaporize part of its surface, turning that asteroid into a rocket. My understanding of this is that you basically set one side of it on fire and it makes itself into a rocket.
Yep.
Is that right?
Yeah. And you know what? We see that naturally with comets. Yeah. So comets, when they're in orbit around the sun, as they come in close and the ices start to off-gas, those jets can push the comets in weird ways, which is kind of cool. So we see that naturally.
But we have never tried this with an asteroid. And now the ideas are getting a little bit less serious. Like there's an idea of an ion beam deflector where basically a spacecraft moves alongside the asteroid and shoots charged particles at it to get it to change its path. Or a cosmic bullet, where we place long, sharp rods of tungsten in the path of the asteroid. And when it hits them, the rods penetrate and break the asteroid apart. Or a gravity tractor, which is like a really big spacecraft that tries to move the asteroid with its own gravity.
I feel like that probably wouldn't be the best option on such a short time frame. You're gonna be, I think you're gonna need to be a little more dramatic about your approach.
After weeks of debate, the space agencies in the world announce that they've chosen option 2, smash it. Here's the plan. The whole world will work together to build and launch 2 enormous kinetic impactor spacecraft. If one doesn't work, the second can get it done. If both work, even better. The goal is to just slightly speed up or slow down Sotir's orbit by just a few millimeters per second, which over the years would cause it to arrive at the impact point either too early or too late, and Earth just wouldn't be there. This is the highest stakes, most complicated mission humanity has ever done, and everyone has to do their part. NASA and SpaceX build one launch vehicle and kinetic impactor, while Roscosmos and CNSA build the other. ESA builds the Observer spacecraft to accompany both. JAXA and ISRO each send spacecraft ahead to sample the asteroid and confirm the math. After almost 2 years of the world pulling together for this mission, in May 2037, Mission Soteria is ready.
3, 2, 1, and liftoff.
It'll take 5 months to reach the asteroid. The world holds their breath as the ships begin their journey.
Back on Earth, I'm still hunting for new asteroids, but it's getting later and later, and I'm losing hope that we're gonna find anything. And then, all of a sudden...
So this score's pretty good. Let's see. Oh, look at that. What do you got?
Is that real?
That was real, yeah. What did you get? So now, the next step, okay, is to determine if this is a new object, okay? Don't get too excited, because it might not be new. So hit the U key.
So we reported what we found to the Minor Planet Center.
Oh my god, the suspense is killing me. This is a very stressful job.
How big do we think that asteroid is?
Based on its speed and where in the sky we found it, it's already getting lit up pretty well. I'm just gonna ballpark it at maybe 50 meters. So.
I'll take 50 meters. That's
Yeah,
a dangerous
it could be a lot
asteroid.
smaller. Could be a
That's
lot
a
smaller.
dangerous friggin' asteroid.
It is a dangerous asteroid, yeah. When the check is finished, they'll email us and they'll say, this was new, this was not new, and if it was new, they're gonna publish it immediately for everyone in the world to see. We can check this page and see if it posted. Oh!
There it is!
Yep. 0 hours ago.
That's our asteroid!
Yep. And my size estimate was not too bad. 56 meters wide.
Wow!
Yep, 56. Yeah, that's not a bad guess. Yeah. This is a brand new asteroid, and you were literally the first person in the world to see it. So.
That's really, really cool. Thank you for setting us up to do that.
Yeah, no problem. And your name's on it.
I still cannot believe that we actually found a new asteroid. That is the coolest thing. As of right now, our little huge if true asteroid is right here. You can go look it up. I'll put the link in my description. You can see where it's gonna go. And luckily, it looks like it'll never hit Earth. But what about Soteria?
On October 20th, 2037, billions of people watch with a few minutes delay as our impactors hurtle towards Soteria. Will it hit? And can it change the asteroid's path to save us?
3, 2, 1.
A direct hit! Telescopes record a bright flash and a cloud bursting off Soteria's surface. Calculations show the impact changed Soteria's orbital period around the sun by a few minutes, a tiny change. But that's all we need. Scientists now believe Soteria will miss Earth. I actually have chills.
Yeah!
I actually have chills. This is real chills. We're gonna live. I love this planet. In 2041, 4 years after our spacecraft smashed into it, Soteria whizzes past our planet, and everyone on Earth celebrates that day.
Soteria is just imaginary, but the science and the human effort here are very, very real. I just stayed up all night with the real researchers who are dedicating their lives to protecting us. I'm exhausted, and they do this all the time. We are one of millions of species to roam our planet, but we are the only ones that can use science and technology to defend us all and all of the rest of life on Earth from space. We are not helpless, not even in the face of an enormous asteroid. I know it might be hard to see sometimes, but there are people all around the world working together to protect us all so that if the day ever comes, we'll be ready. So if you believe that there should be more optimistic science and tech stories, subscribe to support our show. And if surviving an asteroid